And we are in topic 6.6. We're going to tackle example 3. But first, we've got the property of equality for logarithmic equations, very similar to the one that we discussed in the last video for exponential equations. So here, if x is greater than 0, then log base b of x equals log base b of y if and only if x equals y. So your base would have to be the same, and your arguments would have to be equal to each other. Now, we have the power property of logarithms. In our curriculum, we don't have to do topic 6.5. 6.5 covers the properties of logarithms, and there's really only one that we are going to use in 6.6, and it's pretty easy, and it's the power property of logarithms. And so what the power property states is if you have log base a of m raised to the x, what you're going to do is you just take that exponent and you would move it in the front. So let's do an example. So log base 5 of 5 squared, what I'm going to do is I would just take this exponent and move it out front. This could be written as 2 log base 5 of 5. And now here, log base 8 of x to the 6th. Again, you take that exponent and you just move it out. So this would be 6 times log base 8 of x. Now let's go ahead and take our properties and apply them here. We're going to solve for x. So the first thing I'm going to do is I'm going to apply my property of equality for logarithmic equations. And what I'm going to do is I'm going to just log both sides. So log it. Log, I'm going to put this in parentheses because now this whole thing is my argument or the result, equals log of 5 raised to the x. Notice I don't have a b value. It's because it's the common log. My base is 10. Now let's apply the power property of logarithms. So these exponents that you see here, we're just going to bring them out front. So then this is going to be x plus 1 times log 3 equals, I'm going to grab this x, move it out front, x log of 5. And now this is multiplication. What I'm going to do is I'm going to use my distributive property here, and I'm going to distribute this x, this 1. So we are going to have x times log 3 plus, well, if I multiply anything by 1, doesn't change it, so I'm going to write log 3 equals x log of 5. And now again, you're solving for x, so you want to get all of your x terms on one side of the equal sign, everything else on the other. So notice here I have negative x log of 5, or excuse me, x log of 5 here, so I'm going to do the opposite. I would subtract it from both sides. I'm going to do this in 2 steps, I think. So now I can't combine. I have x log of 3 minus x log of 5 plus log of 3 equals, now it's 0. And now let's move that log of 3 to the other side. It's positive, so that means I'm going to subtract it. I now have x log of 3 minus x log of 5 equals, they cancel out here, negative log 3. Okay, I'm still working to solve x. I need to get x by itself. Both of these terms have an x, so what I'm going to do is I'm going to factor that x out. So if I factor it out, I'm going to have x times log 3 minus log 5 equals negative log 3. And now again, I'm trying to get x by itself. Well, it's being multiplied by this binomial. So all I'm going to do is I'm going to divide both sides by log 3 minus log 5. So I'm going to divide log 3 minus log 5. Log 3 minus log 5. And of course, here they cancel out. And I am left with x equals negative log 3 divided by log 3 minus log 5. Now here you're going to use a calculator. And I recommend, I think on most calculators, you will need to make sure that you have your denominator in parentheses. You should, and again, there's so many different calculators and some of them have different ways of inputting. If you do not get this answer, please contact me. So x is approximately, I didn't need to write that again. So this should be approximately, we're going to call it 2.15. If you put this in your calculator and you don't get this, please let me know so I can help you out and we'll figure out how to get that into your calculator. Let's do another. Yep, we have to try it. So here we go. You want to pause the video and then come on back and check your work. Please feel free to do so. Here we go. I'm going to take the log of both sides. Log of 2, 3x equals log of 7 raised to the x plus 1. And now let's use the power property of logarithms. Let's bring those exponents out. I have 3x log 2 equals, I've got x plus 1 here. I'm going to put that in parentheses so I don't make a mistake. Log 7. So on this right side now here, I'm good. I don't have anything to simplify here. Here I'm going to distribute. So let's just bring this down. We have 3x log 2 equals x log 7 plus distribute the 1, that's just log 7. I need to move this x log of 7 to the other side. I'm going to subtract it. So I have 3x log 2 minus x log of 7 equals log of 7. And now let's go ahead and factor this out. I'm going to factor the x out. So we have x times 3 log 2 minus log 7 equals log 7. And now what's in parentheses, I'm going to divide both sides by. I'm going to skip showing that step. We're going to jump right into it. X equals, I'm dividing what's in parentheses out. X equals log 7 divided by, I'm going to keep it in parentheses, 3 log 2 minus log 7. And let's grab the calculator and see what that is. And can I get this without glare? I am working on the TI-30X2S. So I'm going to punch in log 7. I'm going to close the parentheses, divided by, I'm going to start a set of parentheses, 3 log, it's starting a parenthesis again, 2, I need to close that parenthesis, minus log, my argument is 7, close the parenthesis, that closes the parenthesis on that last logarithm. Now I need to close the parentheses on my denominator, so I'll close the parentheses again, equals, that looks like approximately 14.57, we'll call it. And there we go. If you have difficulty getting this on your calculator, please let me know. I'm happy to help you out.